This is actually a photo of a gentleman the gentleman that was injured. It was only about a quarter cubic metre, maybe half a cubic metre of material that hit him, but fractured skull, 2 fractured vertebrae, 18 individual fractures to the rib, and deficit in 1 leg. How much recovery time is that? About a week? Yeah, back to work. It's actually a lifetime of recovery. That's the problem, and that's what we forget about. Anything wrong with this? Oh, sorry. Hey, but I'm just a surveyor. You ever heard that? That's the other thing we're very good at. We were just going to. We were just thinking about it. Well, obviously you weren't. And we just wanted to. Oh, I just wanted to pop in there and put up the survey. Well, yeah. This is the problem. This is the problem with trenching. Is you never know when you're going to get caught. The big thing we see is people not thinking and working through their plans, the before you dig. Because quite often where we see things go wrong is they end up hitting services and they go, oh, well then we've got to build something.
If you do that many digs, you're bound to strike a service at some stage. Is it acceptable though to actually hit anything? I don't think so. So we need to change that thinking, and we need to have people valuing the service for what the service is. We don't know what's on the other end of that service or what people are relying on that service to do for them. So we need to treat them with all the same amount of importance as if it was a gas main or a live electricity cable. Okay, so there's a bit of a lack of adherence. There was an expectation that GPR is accurate. There's a high reliance on GPR out there to find stuff in the ground. It's only a tool, yet we rely on it heavily. And this one here I've talked a little bit about already. It's a different attitude based on what you expect to find in the ground. So guys actually said to me, oh, we'll be really careful if we're working around a gas main. I've seen them hit 5 gas mains. So we don't actually take any more care if it's a gas main. We'd like to think we do, but we don't. I just want to share a little video with you.
Hey, have you seen his girlfriend?
Yeah, I have. Busy, are we?
Yeah, watching you make a pig's ear of it.
Why don't you get off your horse and do it yourself then?
Oh, we'd rather watch a master at work. Now, Gary, I've got a dentist appointment next Wednesday, mate. Do you think I'll make it?
I don't know.
Put him out of his misery, eh?
Come on. He-Man. Wait. Come on, then.
Oh, Jesus Christ! Put it out! Put it out! Oh, fuck me!
Hello, there's been an accident. I don't know, there's 2. One's burnt. He's burnt bad.
Nothing can prepare you for seeing a man, one of your mates, burst into flames. The screams, the fear, the smell. You can't begin to imagine it.
Thanks, mate.
And for what? Because of stupid mistakes.
Will he be all right?
Hospital on standby, please. ETA 15 minutes.
Of course, if we had our time over again, we'd do things differently. But you can't turn back the clock, can you? You get a bit complacent about working just a few feet from lethal current.
Got it!
25,000 volts overhead, 750 DC on the live rail, 33,000 in a buried line. Don't matter. That's what we do every day, innit?
Watch yourself.
Hello there, Gary. Any time today, mate?
We talked about it in the briefing, but none of us took it that seriously.
All right, lads, listen up a minute, please. Right, we're putting up 250 metres from this point here to the tracks over there.
Oh yeah, what time's lunch?
You just think, let's get in there and get on with it. I should have said something.
OLE cables on the tracks
But I
on
didn't.
our side, and we've got buried services showing from here to here.
I bet a tenner. None of us are like that at home.
Come and get your food. Look. Honestly, Gary, it's going to be like Fort Knox by the time you finish.
Got to keep the little man safe, haven't we? Hey.
Oh, what's Daddy like? Is he keeping you safe?
The fact you can't see it or touch it makes it more dangerous, not less, doesn't it?
Yeah, hang on a sec, John. So it's just this one area to look out for here, yeah?
Oh, great. Should be done by lunchtime.
Walk in the park for you, Steve? Oh, sorry, mate, I've got to take this, yeah?
Bye. See you later.
See you, mate. Daddy.
Bye. Oh.
Ooh. Bye-bye. See you later. See you. Bye.
We all had plenty of chances to do things differently. Plenty of chances to be safer.
Oi, JJ. Ask Danny about last night.
Come on, what happened? Went on a date.
Yeah, what was his name?
Oh, fuck! Yeah, try and get some in the Jenny, you pervert.
Stink now. Well, you stink anyway, so...
But like I said, we can't turn back time.
We have a 34-year-old male received a highly electrical shock, 5% burns, kilo 9, ETA 45 minutes 7.
Right, lads, we can unload, but nobody is allowed in the work area until JJ has finished the scanning, right?
Danny was lucky.
We've changed the way we do things now. The team's got a different attitude. We look out for each other and no one's afraid to say if they're not happy about something. It shouldn't take an accident to make us change the way we do things. Think about it before it's too late.
We came out with this little definition to work with. If a service is on a drawing and we know about it, it is preventable not to have a service strike causing damage, because occasionally we do come across a service that's in the ground that we don't know about. Okay, I'm not saying it's acceptable to hit it, but we're going to get the occasional time where we just don't know about it. We need to be reasonable about it. We need to actually acknowledge that. And then the other question was, what are the corrective actions you're going to implement? So these were the key learnings. We're not doing what we say we're going to do. We weren't following our processes. And we had supervisors appointed without training them. Our contractor system wasn't implemented effectively, and our risk management wasn't effectively implemented.
This picture is also the scene of an incident. Looks like quite a regular excavation going on there. There are three key elements of safe digging practices. And on this job here, those elements were actually being followed in a lot of ways. The plans had been obtained, a service locating device had been used, and some service locations marked in dazzle on the ground. And some potholing by hand had taken place. Work also involved the use of an excavator. PPE was being worn. There was some planning and some good practice. The picture on the left shows that the hazard of electricity had been identified. They'd actually marked the control as being plans to be used. Also, machinery was identified as a hazard, with hard hats as a control. The plans showed multiple services and their depth. It's important to remember that despite plans, services can be found at any depth, regardless of what depth they're shown on the plan, and to stay clear of excavators when working. Shovels and spades were being used correctly, not spiking into the ground, and digging to the side of the services. Remember, excavators are the main cause of danger. They should actually not be used within 500 millimeters of a service. Again, services can be found at any depth, and may not be shown on plans. And an important rule is keep clear of the excavator while it is working. So here's what happened. The excavator struck a cable at a shallow depth. There was an arc and an explosion. It actually burnt a hole in the bucket of the excavator. The man on the shovel took the full force of the explosion. His protective eyewear saved his sight. Note the charring on the hard hat you can see in the picture on the right. He was wearing the glasses that are on the grass there. So what needs to be controlled when excavating? It's not just about trench collapse and the dangers of service strike. Consideration of falls, safe access and egress, where spoil is positioned adjacent to excavations and plant as well. Hazardous atmospheres can be a killer. Specialist equipment is needed and training in order to monitor levels of contaminants in the air. Contaminants in the soil is a possibility also. Traffic management is important as well as emergency procedures. So there's a lot of things that need to be considered. It's important to ensure workers are inducted, adequately trained for the task, and wearing the appropriate PPE. This picture here, actually, it does show a lack of controls. It's on the scene of an incident. Excavations over 1.5 meters deep are particularly hazardous, and therefore specific legislation relates to that depth. It's not to say that excavations below 1.5 meters are not hazardous either, but it's particularly recognized through legislation. Deeper than 1.5 meters, the following regulations apply. So there's regulations 24, 25 and 26 that prescribe some law. 24 is that if an excavation is over 1.5 meters, that it does need to be shored or cut back to a safe slope. And that must be undertaken by law unless it's proven, that means by an engineer, that there's safe ground conditions, so it's stable, or that no one is in danger. That means that no one's actually going to go into the excavation. Regulation 25 is, again, where if there's a risk that an excavation can hold water and it's deep, so in other words, someone may fall into that excavation or someone may fall in and drown, that excavation needs to be covered or fenced. And Regulation 26 is about notifying us, the regulator. So basically, again, if the trench or excavation is 1.5 meters deep and it's narrower than its depth, then it needs to be notified to the regulator. Faces over 5 meters, if they're steeper than a 1-in-1 gradient, they need to be notified to the regulator. And also, if an excavation has overhead cover, then it needs to be notified to the regulator, and that is law. So what will our inspectors be looking for when they're out in the field? Our inspectors will expect to see what is in the approved code of practice and guidelines. WorkSafe has a goal or vision that everybody who goes to work comes home safely and healthy at the end of each day's work. When it comes to excavations, there are simply no excuses. The law is prescribed, the information is available, the controls are known. There's actually a lot of safety leadership from the top of companies right the way down to the bottom here in Canterbury that we're not seeing over the whole country.
So looking at our actual excavation, the depth and the ground conditions would indicate some of the more serious hazards, and of course that would be ground movement or collapse, especially if there are going to be workers in there. We're going to be looking quickly at some of the methods to ensure that there is no collapse or to prevent dirt falling in. And one of them, quite obviously now, is the side and the area that the spoil or the excavated ground is stacked and placed. The distance from the edge to where the spoil should be is now recommended at around 600 millimetres. It should and will be changed to about 1 metre. So 1 metre back, usually on one particular side of the hole if it's possible, so that there's good safe access and egress and an emergency evacuation on the other side of the excavation. Any excavation that is 1.5 metres deep, about this high, needs to be notified and extra conditions should be put in. But whether it's a notifiable hole or not, you should always consider the fact that the ground can cave, especially when workers are going to be working in there. 2 out of the 3 methods we'll be looking at are present here. Of the techniques and systems used to ensure that the ground doesn't collapse and stays solid, especially for the workers in there, on this side we've got a demonstration of benching. And benching is the practice of stepping up and in and up and in. So for every metre up, 1 metre in, 1 metre up, 1 metre in, simulating sort of a 45-degree zone. On this side, we've got battering or sloping, and this is one of the preferred methods because while loose spoil and soil is taken away, the ground can be compacted, also ensuring once again that there's not going to be any collapse. Have underground utilities, the water, the gas, the sewer, the telecommunications been identified? How are they marked out or how they worked around during the excavation? And of course at the same time looking up and around to ensure things like phone, power lines and even trees, overhangs, bridges and other obstacles have been identified and controlled. I'm standing on a trench shield, and this trench shield cover is designed of course to isolate the hazard of falling into the excavation. You want to make sure of course these are designed to be walked on, as I've done, and whether or not they'll take mobile plant. These excavations don't have to get too deep, and especially in and around operating generators and operating machinery can easily fill with fumes and dangerous gases, or gases could also arise from the environment in which you're working.